We're going to evaluate the integral of the square root of x squared minus 1. We'll be using trigonometric substitution, and this is a type of trigonometric substitution that when we have a radical of the type x squared minus a squared, so the substitution is x equal to a times the secant theta. This will be the substitution so that the radical will be eliminated, will make integration easier. In our problem, we match a squared to 1, so a squared equals 1. We can take a to be positive 1. So the substitution that will work in this problem will be x equal to secant of theta. From here, we need to differentiate both sides. So dx becomes the derivative of secant, which is secant theta times tangent theta d theta. And then we need to replicate what's inside the radical. We're going to square both sides. So x squared becomes secant squared theta. In the radical, we have x squared minus 1, so we'll subtract 1 from both sides. X squared minus 1 is secant squared theta minus 1. And using the basic trig identity, that is tangent squared of theta. So now our integral can be rewritten. Inside the radical, we put in tangent squared theta, and then dx would be secant theta times the tangent theta d theta. We can assume that square root of tangent squared is tangent, so we have tangent times secant times tangent all of theta d theta. Now simplifying this, we have the integral of tangent squared theta times secant theta d theta. The way we solve this integral, I think this was done in an earlier video, is to replace tangent squared again with secant squared minus 1. So this is secant squared theta minus 1 times the secant of theta. And so we have two integrals. We have the integral of secant cubed theta d theta minus the integral of secant theta. You must memorize or know how to integrate secant cubed and secant, because many problems in this section, that is using trig substitution, will eventually end up as either secant or secant cubed or some kind of combination of these. Now, a secant cubed was derived earlier as well as secant, so you can search for in earlier videos where secant cubed is done by integration by parts and secant is solved by just regular substitution. I'll go ahead and work this again. I will not do a secant, but I'll go ahead and solve for secant cubed, but using reduction formula. The reduction formula for secant is secant to the n of theta d theta is equal to 1 divided by n minus 1 times secant to the n minus 2 of theta times the tangent of theta plus n minus 2 over n minus 1 times the integral of secant to the n minus 2 of theta. So in our case, n is equal to 3. So the integral of secant cubed of theta d theta is equal to 1/2, just replacing n with 3, secant theta times the tangent theta plus 1/2 times the integral of secant theta. So now we can combine this. Let's go back to the problem. Our original problem was we wanted to integrate the square root of x squared minus 1. We made the substitution x equal to secant theta, and we ended up with the following. We ended up with the integral of secant cubed of theta minus the integral of secant of theta. Now we just used the reduction formula. The integral of secant cubed is 1/2 secant theta times the tangent theta plus 1/2 times the integral of secant theta, and then minus the integral of secant theta. So this simplifies to 1/2 times secant theta tangent theta minus 1/2 times the integral of secant of theta. And the integral of secant of theta you should memorize. So this is 1/2 secant theta tangent theta minus 1/2 times the natural log of absolute value secant theta plus the tangent theta. Now what we have to do now is to express the final answer in terms of x. Our original substitution was secant theta equals x, or we can write it as x over 1. And so we can draw this right triangle. This is angle theta. Now remember, secant is hypotenuse divided by adjacent. The opposite side then will be square root of x squared minus 1, as you can check by the Pythagorean theorem. And now we're ready for the final answer to this problem. The integral of the square root of x squared minus 1 dx is equal to 1/2 secant theta, which is x, times tangent theta. Notice from this triangle, tangent is opposite over the adjacent, so that is just square root of x squared minus 1 over 1, minus 1/2 times the natural log of absolute value of secant theta, which is x, plus tangent theta, which again is square root of x squared minus 1, plus constant of integration c. For more